Hello everyone. I'm Mitsutaka Takada. I'm a researcher at Nagoya University in Japan. So I'm research scope on software platform using SpaceWire protocol for spacecraft, and AutoSAR is a specification is for automotive. So today's report is platform porting cFE to spacecraft onboard with SpaceWire engine and RTOS based on micro-ITRON specifications. So do you know the micro-ITRON specification? Do you know? Everyone knows. Thanks. This report is part of R&D joint research between Nagoya University and JAXA.
I think there's something. The screen share. Yeah, okay. It's not working. I think this one. Yeah, here. Go ahead. Thank you.
Thank you. Table of contents. Motivation. First is a motivation to use cFE. Why reason we examine the cFE. As next topic is target board is SoySock3, and our real-time kernel is micro-ITRON based on Topaz OS based on micro-ITRONs. And main topic is cFE supported by Topaz OS. And motivation to use cFE. In Japan, the SpaceWire is adapted as an inter-satellite network, mainly for medium or large science satellites. So by using SpaceWire, flexible network configuration and remote access with RMAC protocol become possible. But at the same time, application developers are required to increase SpaceWire request knowledge. So in satellite application development, we think that building a software platform such as cFE, SOAS, and so on will be important, so that we examine the use of cFE and porting for spacecraft onboard in cooperation with JAXA and Nagoya University. So what conditions spacecraft are of our software platform? So in considering the software platform, we conducted a survey with following. First one is application can use SpaceWire protocol service. This is because that SpaceWire communication as an application will continue to increase. Second is open standard API or open source software. This means that we want to freely use specification and source code. And third, specification is available both within and outside Japan. Joint mission project members are not only in Japan but also overseas. So we need a license or API information that can be used everywhere and everyone. So we started to focus on the JAXA's guideline in internal documents and the SpaceWire onboard subnet design standard, and SOAS for ESA and cFE on NASA information. So SOISOC 3 is a target, we target the onboard applications. So MHI, Mitsubishi Heavy Industry, and JAXA developed the space-grade system on chip processor. SOISOC 3 is target highly reliability severe environment applications. So second generation is SOISOC 2 has been inside a large number of satellites in Japan, and its use also used in commercial product. This is AstroCam is used as a radiation monitor at nuclear power plants, and SOISOC 2 has been several satellites inside of space scientific satellites AstroH and geo exploration satellite ELG last year. And SOISOC 3 microprocessor is our new space-grade system on chip processor, which is currently being developed by MHI. And SOISOC 3 has high reliability SpaceWire engine, which MHI has developed the supporting for incoming SpaceWire standard. So SpaceWire D is deterministic data delivery protocol with SpaceWire timecode. And SpaceWire R is reliability data transfer service. It is like TCP service on SpaceWire. So a SpaceWire engine is mainly performance on hardware on SpaceWire SOISOC 3. In SOISOC 2, we developed a SpaceWire protocol stack, which is support ARMA protocol and SpaceWire D protocol on software. As a SpaceWire engine, MHI reference to implementation of our protocol stack. So high scheduling and high performance with less CPU load. And next, micro-ITRON, Topaz HRP2 kernel is Nagoya University and JAXA have developed the micro-ITRON OS for space system about 10 years ago. It's additional to the memory protection function in the kernel of micro-ITRON specification. So object access management and mutex and overrun handler functions. So we call them the HRP kernel. So Topaz OS is planned to be used in some space systems, and it used on the avionics on H2B rockets. So we will now developing HRP kernel version 3, and we will release HRP3 kernel at Topaz project on next year. HRP3 kernel main topic is addition to time protection. So what's the Topaz project? Topaz project aims develop the various open source software for embedded system, including RTOS, and promote these use. So incorporate as a non-profit organization in 2003. So application Topaz OS is widely used in industry in Japan. So commercial application, industry applications, automotive system for and space systems. So recently we have developed RTOS not only the micro-ITRON specification but also AutoSA specification. AutoSA is controls automotive control systems, which is in vehicle in software platform. So main topic is porting OSR. These OSR and cFE version are starting point to implement. So before the porting OSR, we referred these informations. First one is the OSR source code and document, and OSR configuration guide was very useful for gathering information on parameter files, such as how to build cFE. And OSR library API document was effective for understanding API behavior. It helps us judge whether HRP2 kernel has equipment functions. And function test, unit test, we implemented all the function by using this test step by step. We learned how to use BSP start.c file and develop it. And second is JAXA has been tried to port cFE. So I received the source code from JAXA. This project is too easy to porting, but however, it was minimal support function of learning cFE. So we developed the porting cFE as fast as study. It was a restriction since the RTOS function are not extended. So we developed the start points porting cFE. And RTMS implementation source code and build script. RTMS API parameter is similar to micro-ITRON specification. So we implemented it with reference to the RTMS source code. Very useful. So breaking point of all the PSP porting on Topaz OS. Topaz OS, it is a very minimal RTOS, so several breaking points. First one is Topaz OS and micro-ITRON not support the file system functions. This is support file system function support is optional. And SoySock 3 has only memory storage, so not large storage devices. SoySock 3 has a flash memory, which is only used by binary application programs. So Topaz OS is not supported the standard I/O function, so another implementation of UT-assert functions. And last one is a different build system and bootstrap from other OSs. So Topaz OS extended for cFE. So these issues Topaz minimum function for RTOS. So we extended the Topaz OS for cFE. First one is create or delete and delete APIs on all the API are supported. And we support the using FATFS is open source generic FAT file system module we developed into the Topaz kernel. And the implementation of alternative printf functions. And we decided to not support cFE functions, dynamic load and symbol API and network APIs. this is a corresponding table of all the API and HF2 kernel APIs. So Q APIs, OS, Q, blah, blah, blah APIs are equipment to the Topaz data queue functions. It is like wrapper function code. It's very short code implementation. This circle icon implementation of native source code. This is referred to Artemis. And task control API. There is almost realized by using API of Topaz HF2 kernel as it is. At OS task get ID by name function is a very unique function on micro-ITRON systems. Because micro-ITRON systems specification tasks are managed by task ID numbers. And OS task register function is not implemented yet. So because of I don't know how to different from OS task create functions. Maybe OS task register function is only registration of task control block. It means that task state is not running. Please tell me how to use these functions.
We could help you there. Yeah.
And SOISOC3 BSP configurations. Parameter of OS config.h, we undefined the OS include network and OS include module loaders are undefined. So, and how to boot up from OS, Topaz OS to OS BSP main functions. So we provide a BSP initialize function that name BSP init Topaz functions. First one creates a startup task on for Topaz OS, and second is this task is called by BSP init Topaz function, and this function runs the initialize BSP and finally calls OS BSP main function. It's running to cFE. And how to configure the Topaz OS by cFE. Topaz OS uses configuration file at precompile time. At first, especially parameters of this is a block the Topaz configuration files. This block is especially parameter of the kernel object used in the cFE applications, such as the maximum number of tasks and data queues defines. And the next block is specifies the mutex and the semaphore necessary for all the implementation. And cFE support by Topaz, all the porting, Topaz HF2 kernel support all the API except dynamic loader and symbol and network API. And alternative printf function for UTR-SAT functions. And PSP porting, SOISOC3 configures configuration for PSP on memory file system using. And next, the cFE test running. So we conducted the following test for confirmation after porting. So we ran these tests step by step, all the implementation. All the function test is several functions you used. This functional test is a passed. And next, cFE sample applications. We will build a sample app and perform test. We can run these sample applications. So but the results analysis are not yet not carried out yet. So conclusions, cFE is supported by Topaz OS, and cFE application can run on SOISOC 3. And feature plan SpaceWire support the SpaceWire. So we must use a SpaceWire application on cFE, and SpaceWire sample application on cFE. And next, the enhanced SBN configuration. So SBN support only RMAP protocol on SpaceWire, but SpaceWire engine supports not only RMAP but also SpaceWire D and R protocols. And incorporate network time management setting into SBN. It means SpaceWire D and R required time management, time code, and timeout. Thank you.
Thank you.